So our next topic for solution of equations in one variable is accelerating convergence. So from the term itself, accelerating convergence, we can speed up our solution by using these methods, wherein we will not anymore conduct a lot of iterations for us to get the roots of the given equation. So the first method that we will use is Aitken's delta squared method. Aitken's delta square method. So this is one of the steps in accelerating the convergence of finding the roots of an equation. So this method is useful, okay? This is useful for accelerating convergence of sequences that run linearly, okay? So whenever an equation is a sequence that runs linearly, we can use the Aitken's delta square method. And actually, this method was named after Alexander Aitken, way back in 1926. So the steps in solving for the Aitken's delta square method are as follows. The first step is we pick a value of x of 0, wherein x of 0 is within the interval of the roots of the equation. Second, by applying fixed point iteration, okay, by applying the concept of fixed point iteration, we can say that we can get x of 1, which is equal to g of x of 0, and we can get x sub 2, which is g of x sub 1. If you'll recall on our past discussion of fixed point iteration, we get the values of x sub 1 and x sub 2 or x sub n plus 1 by just substituting the past values of x. The next step is we solve for the equation using the Aitken's delta square method. And the equation goes like this. X sub 3 is equal to, so this is the formula for Aitken's delta square method, wherein x sub 3 is equal to x sub 0 minus the quantity of x sub 1 minus x sub 0 squared all over the value of x sub 2 minus 2x sub 1 plus x sub 0. And then the fourth step for using Aitken's delta square method is that we set x sub 3 as x sub 0 and continue with the iterations. So we just repeat the same process, okay? And on step 5, we continue until convergence is obtained. Okay? So for example, we need to find the root of an equation. So we need to find the root of x e raised to x minus 1 is equal to 0. So by using fixed point iteration, we can say that x e raised to x is equal to 1. Okay? And then you just divide both sides by x, by e raised to x. We can say that x now is equal to e raised to negative x. And therefore, we can now use the fixed point iteration because we now have g of x which is equal to e raised to negative x. And the interval is given also for this example, that the interval is between 0 and 1. So if we will check for the equation if this is converging or not, so we just get its differential or its derivative. So its derivative is negative e raised to negative x. And if we will substitute a value of x, wherein we can say that x is equal to 0.5, therefore g prime of x is equal to 0.6065. And based on our fixed point iteration, if this is greater than 1, therefore our equation is converging. So it will lead us to the roots. So by applying Aitken's delta square method, we can set the value, or we pick a value of x sub 0, let's say 0.5. Therefore, we can say that x sub 1, or also g of x is 0, is equal to 0.6065. And we can compute for x sub 2, which is g of x sub 1. So we just substitute the value and we get 0.5452. Okay, so when getting for x sub 3, we use Aitken's delta square method. So the formula is x sub 0 minus x sub 1 minus x sub 0 squared all over x sub 2 minus 2 x sub 1 minus x sub 0. Okay, so that's plus x sub 0. So we just substitute the values. We will get x sub 3, which is 0.5676. So after getting the value of x sub 3, which is 0.5676, based on our steps, we set this as x of 0. So we get now x sub 4 by just substituting 0.5676 with our g of x. And the value will be 0.5669. Substituting the value of x sub 4 with g of x, we get now x5, which is 0.5672. And by applying again Aitken's delta square method, so we use the formula x sub 3 minus x sub 4 minus x sub 3 squared all over x sub 5 minus 2 x sub 4 plus x sub 3. And we get the value of x sub 6, which is 0.5671. And after successive iterations, so we get the approximated value of the root, which converges at x is equal to 0.5671. So when we compare this method with fixed point iteration, we can say that this is much easier because it accelerates our convergence faster than using the fixed point iteration. So that is the advantage of the Aitken's delta square method.